In this video, we will create another stream performance example and we'll run a few operations like map to object and sort it on the parallel stream and then compare the performance with sequential. So let's create a new class, and the name of the new class is stream performance example 1. Let's create public static void main, and also we'll create two static methods to calculate the sort and sequential sort sequential stream, and the other static method to sort parallel stream. And also we'll create a class random tokens, and this random token will contain integer ID and long tokens. So we'll be using this class as an object and map the int stream or long stream to objects. And generate constructor using both the fields, and also right click generate getters and setters. That's all for the random token class. It will have one integer ID and long tokens. It's just like database where you are storing tokens with the IDs in sequential order and tokens which are generated randomly. So let's implement the sort parallel stream first. So here we'll be generating a list of random tokens. Random tokens is equal to int stream dot range close, or maybe we should use the long stream this time. Long stream dot range close 0 and token count. We'll define this variable token count at the class level. Dot parallel dot map to object. So we are mapping this to object, which is the random token object I, and return new random token I, and thread local random dot current dot next long, and the bound for long is also token count. Token count is a variable which we'll be defining, or maybe let's go ahead and define this. Static long token count is equal to 50,000. So it will generate a long stream of from 0 to 50,000 because token count is 50,000. It is complaining about I, so here make this long also. Required type integer, provided long. We'll have to regenerate our constructor and getter and setter because I changed from integer to long for the ID. So let's go ahead and generate and constructor again, and getters and setters. Okay, so now this error is gone, and so we are generating the next token. And now let's collect this, collect, and collectors.toList. Okay, now we'll be sorting this stream. So random tokens dot stream dot sorted, and comparator is comparator dot comparing, and random tokens get tokens. So it will be sorting on the get tokens, and return -1 because we don't need this return value, but as it is supplier, it requires one return value, so we are returning -1. Now let's implement the sort sequential stream. So let's copy this and then paste it, and here we have to modify this to parallel dot sorted so that it runs sort operation in parallel. And when we are also generating this long stream dot range close dot parallel dot map to object. Okay, now let's remove parallel from here. So our sort sequential stream is basically generating a stream and then converting them into object in sequential order and then sorting them in sequential order. Now let's create a method, public static long measure performance, and here the argument for the measure performance is a supplier, and it will be a supplier of long, and supplier, and int, and long is the, or int is the number of times we'll be looping through. So number of times. Now long start time is equal to system dot current time dot millisecond. So we are getting the system current time in the start time and looping for integer I is equal to 0, I is less than number of times, and I plus plus, and calling the supplier dot get, and afterwards returning once it calls supplier dot get the number of times, then it will return the time. So time will be system dot current time millisecond minus start time. Now inside public static void main, let's create a variable loop is equal to 20 because this is the number of times we'll be looping, and long result is equal to measure performance and stream performance 1 dot or colon because we'll be calling those sort sequential stream first, new line, and then loop. And not convert into java.language.long because the result is int. Cannot convert. Here we have to find the integer, so let's convert this to long. So this will take care of the error. Now let's print out the result. Time taken to process sort in sequential plus result plus milliseconds, and afterwards call result is equal to measure performance and stream performance in this sort parallel stream, and loop, and print out time taken to process sort in parallel plus result plus milliseconds. So let's go through the program again. So we have created a method sort parallel stream. Inside this parallel stream we are generating random tokens by using long stream.range close 0. In this case token count is 50,000, so it will generate long stream from 0 to 50,000, and then afterwards we are running in parallel and then mapping to object. So in this case I is the value which we'll get from the long stream, so it will enter in, it will create this value in the long stream random tokens integer or long id. So the id will become the, for example, if the stream is 0, then 0 and thread local dot current dot next long token count, so it will generate a random number and it will store this object in the collectors dot toList. So random tokens will contain a list of 50,000 numbers, and then afterwards what we're doing is that we are sorting this random tokens, converting into a stream, and then dot parallel operation on this one, and then sorting it, and our comparator is random token get token. So it's sorting by get tokens, which is our tokens. Same thing for the sequential stream, because sequential stream, the only difference between sequential stream and parallel stream is that here we were creating the long stream.range close in parallel, here we are creating in sequential, and we are sorting also in sequential. Now measure performance. Measure performance is basically a supplier. It takes a supplier argument. In this case, if you look at this one, it does not take any argument and just return a value, which is an example of a supplier. So it takes a supplier and then integer number of times is going to loop through. So here we are starting our counter. Start time is equal to system.current_time.millisecond, and then we are looping the number of times which are specified in the attribute or the parameters, and then we're calling supplier.get. Supplier.get will basically initiate the processing either of the sort sequential stream or sort parallel stream, and then it will loop through 20 times, and then afterwards we are measuring the time it takes to complete this task. Here we are calling long result is equal to measure performance. We are calling measure performance and then passing on the reference to the sort sequential stream. Method reference, using the method reference stream performance example 1, the name of the class, and then sort sequential stream, and then the loop, that how many times it needs to loop through to measure the performance, and then afterwards this result will contain, so here we are returning the time it takes to complete the processing of this operation. So this result will contain the time it will take to process the operation, and then we are printing out the time taken to process in sequential order in result, and then afterwards we are measuring performance again using sort parallel stream, and we are printing out time taken to process sort in parallel and result and millisecond. Now let's run this program. So you can see that time taken to process sort in sequential is 106 milliseconds, whereas time taken to process sort in parallel is 80 milliseconds. So parallel processing is definitely helping us to improve the performance of our system or improve the performance of our program.